temperature evaluation module.
Hi guys, we're working with TI on a high temperature evaluation model. My name is Derek. That's Taha, Caitlin, and Pavel. What basically our design is for is to solve a problem that when you test things at high temperatures, it's obviously very difficult to do. Now, what we're specifically working on is a reference board that works on 5 TI high temperature design amplifiers, which once you try and test high temperature, it's going to cause a lot of problems. And essentially that you need everything to be high temperature in order to test efficiency. Now, with the current setups and designs, you have to do this individually, testing a single parameter at a time. What our board designs to do is essentially develop a board that's easily customizable in order to test any parameter, specifically DC in our case, that can be used for any of the set of amplifiers at free will. So in doing this, we've moved on with our design goals. Now, the first step that we did was to conceive and design the board. Now, to start with this, we started designing certain circuits which can be used to design DC parameters, eventually moving into AC with parameters such as noise, but for the most part, we focused on things such as input bias voltage, and then offset voltage, or input as bias current, offset voltage, typical parameters that you'd want to test across an amplifier. Now, obviously, when you move into high temperatures, these parameters change greatly and their ranges change. So testing something at room temperature is also going to be possible. By doing this, we can design a board which can basically be put in an oven and then tested easily without having to swap out any components based on you swap out components based on what you want to test at the time, rather than having to set up the board, test it, take it back out, set it back up again, and etc. So with this in mind, we started with a single design phase, moving into the circuits, then moving into Altium design in order to devise a schematic. Pavel mainly worked on the schematics design, while I mainly worked on the test circuits, with Caitlin and Taha working on the actual testing of the circuits in lab. Now with this, we've started our design schematic and we're nearing completion of the schematic. The next step is obviously to transfer this to a public PCB. Now with a PCB, it obviously has to be a specific type because you can't use regular components. Everything has to be rated for 210 degrees Celsius, which is extremely high temperatures suited for applications in the real world, such as oil drilling, things such as that. Anywhere electrical equipment would be right next to the high temperature machinery. So with this in mind, we're moving into the design, we've moved past the schematic design, we're finalizing that, we're moving into the design of the printed circuit board. And with that, we'll move into the next design phase, which is to actually test it, and then add any more components that be necessary. But in the end goal, our design is to test all the DC parameters for those 5 particular op amps. So with that in mind, I'll open it to questions.
Two minutes for questions. I'd like to ask one, have you thought about your testing regime?
In addition to the schematic, we have a full process that includes the removal of adding the components that you need to do. For instance, across a particular op amp, if you need to add an RG or a gain amplifier or gain resistor, you can add that based on the schematic that you design. We have an entire process that is
given by TI process?
No, we had to design the process. We were basically told which parameters to test, and we designed the process to test them.
So are you putting all of your equipment into the 210 oven, or are you doing it outside of the oven if you're bringing out the...
There'll be singular test lines running into the oven. Like, of course, the actual testing equipment won't be in there. The entire board will be in the oven with singular voltage lines or current lines, depending on what you need.
You're designing electronics that would be in the oven.
Yeah, yes. And it can be tested outside the oven or inside the oven. But obviously, if you're testing, for instance, like we wanted to run, the eventual plan is, leave the circuit board in like a 200-degree oven for a couple of days. Then we can have singular test lines running to the equipment so you can easily test the parameter that you're looking for.
So you said that EA asked you to test certain parameters. Did they ask you that much, or did they give the testing procedure as well?
Say the last part.
Testing procedure as well, or
we designed the testing procedure. Basically, the main focus is to focus on DC parameters, so input, bias current, offset voltage, gain, things such as that. And then we've added things, and we'll continue to add footprints. We've added AC noise. So as time goes on, we can add more things, and the board can be customized based on an individual request. Say someone wanted to test something else, it could be added to footprints. But individually, we haven't